Here we're going to go through another 3 worked examples on how to apply the index laws. We look at the first one. Once again, we just start by writing down the question, which is 125 y to the power of 9 or raised to the power of 2 over 3. And I suppose rather than just do it, I'll just tell you what you start thinking about. So we've got some brackets around here, so we know whatever the power is outside has got to be applied to both or everything that's inside. So that's something to keep in mind. And the other thing is that we've got an index power. So we've got power to a power going on, and then we've got to be familiar with our index laws as far as fractional powers go. So we firstly expand the brackets. So we've got 125 to the power of 2/3 times y to the power of 9 to the power of 2/3. So we put brackets around y to the power of 9 to show that it applies to just the y and not anything else. And we say, well, oh boy, what have we got here? We've got 125 to the power of 2 over 3. There's no powers there, so, and to square this, you've got 125 squared and then to find the cube root of it. So maybe it would be better to find the cube root of 125. That's one that probably you should know, the cube root of 125. A number which multiplied by itself 3 times will give us 125. It's going to end in 5, isn't it? Or our number's going to have a 5 in it somewhere. So that's probably not too difficult to do. So we've got the cube root of 125 all raised to the power, well, that's a cube root there, put a 3 there, all raised to the power of 2. So we've got to find the cube root of 125 all raised to the power of 2. And then we've got a power to a power, so we times the index. And cube root of 125 is 5, and we've got 5 squared, so that's 25. So the cube root of 125, a number multiplied by itself 3 times, there's going to be 105 is 25, another 5 times 25 is 125, so that's good. And then we've got to square the 5 to get the 25. And then we've got y to the power of 9, now that's 9 over 1. And from our knowledge of multiplying fractions, we could multiply the tops, multiply the bottoms, or we can try and cancel first. 3 into 3 once, 3 into 9 goes 2, 2 times 2 is 4 over 1. So it'll be y to the 4 over 1, 4 over 1 is the number 4. So that is simplified. Simplified means remove brackets, make things a little bit easier to well, we can simplify, just like you have to simplify a fraction 4 over 8, you would say it's 1 over 2, or simplifying using indexes is to remove the brackets and make it as simple as possible. So that's A. B, we've got a squared over 16 all raised to the minus 4. Now, we've got a power raised to another power, so we times the index. Now, 16 is 16 to the power of 1. And so when we multiply out, the negative 4 is going to be multiplied by both powers. So that'll be a to the negative 8 over 16 to the negative 4. So that negative 4 has got to be multiplied by that power and that power. Now, we can apply another index law. If it's got, we know that a to the minus n equals 1 over a to the n. And basically a to the minus n is like that over 1. Well, you put it downstairs with the positive power. But if it's downstairs with the negative, you bring it upstairs with the positive. So as I've said before, that it is normal and it is a convention to express this with positive powers. So that can go down to the positive 8. And because this is downstairs with a negative, it can go up with a positive power. And then it's up to you whether you work out 16 to the power of 4. Probably not much mileage in doing that, so just leave it as it is. But once again, you can see that there's no negative powers expressed there. I've gone all the way to get the positive powers. And the third one, we've got, once again, I'll just write it down, 4h to the 4th, k to the minus 2 times h squared. And as I'm doing this and as you're writing it out, you're thinking, now what index laws am I going to use? I've got some brackets there, so maybe I'm going to get rid of the brackets first. And another technique for this is to simplify the numerator, get that all as a single fraction, get this all as a single fraction, and then see what can be cancelled down at the end. So okay, well, as we were writing it out, we were asking ourselves how we're going to do it, and we've decided we're going to simplify the numerator and simplify the denominator. But even before we do that, we've got to remove these brackets. And when you've got a power to a power, you times the indexes. So 4h to the 4th, k to the minus 2, that can't be simplified. Times, now power to a power, we times the indexes. So negative 3 times 2 is negative 6. And that's like k to the power of 1. Negative 3 times 1 is k to the negative 3. Here we've got a power to a power going on as well, so that'll be 2, and that's to the power of 1, so 2 times 1 is 2, and that's h to the power of 1, so times that 2 is h squared, times 6 to the minus 2, k to the minus 4. Okay. I think that we can now multiply these out. And I'll just clarify one thing is that we can look at the top here and we've got 4. There's a 1 there, so 4 times 1. Now we can combine the h's together, and when you're multiplying the h's, the same base, you add the index, so that'll be h to the minus 2. And then we've got k times k, but we've got negative 2, negative 3, so we're going to add those, and it'll be k to the negative 5. We've got 2 to the power of 2. Now I'll talk about how we're going to, we'll just leave it down here at the moment. We'll talk about how we're going to deal with that in a minute. And then we've got h squared, and then we've got k to the minus 4. All right. I would think it would be better to leave the 4 there on the top. Now because this is 6 to the minus 2 down here, it can go 6 to the positive 2. So maybe just put a little line through things as we get them taken care of. 2 to the power of 2 is 4. That can go down the bottom, so we've got all that taken care of. Now we look at the h's and we say, well, where are there more positives? There are more positives down here, so it looks like the h's are going to stay there. 2, and because this is like dividing that into that, it'll be 2 minus negative 2. And there are no positive powers of k, but this is not as negative. Negative 4 is not as small as negative 5, so we'll go k to the negative 4, take negative 5. Okay, so that was a bit tricky. the h's, there are positive powers here, negative powers up there, so we're trying to get these powers to be positive, the answer. So we'll get that downstairs. We've got -4, -5 on the number line. -4 is not as far to the left as -5, so -4 is bigger than -5. So when we subtract that, we're going to get a positive, which indeed is what happens. Okay, so the 4's will cancel. And we've got 6 squared, which is 36, over 2 minus -2. So negative, negative, that means you're going to go back, then you're going to go to the positive, so that'll be 2 plus 2, which is h to the power of 4. And then -4, it's going to be like adding 5. So if you start at -4 and add 5, you're going to end up at +1. We'll just go +1. You don't really need to write that +1 there. We could just leave it as k. And that's the answer. So we've got our powers, so we will just write it again without that 1. I don't like the look of that. h to the 4, just k there. So try and express your answers with positive powers. Simplify the numerator, simplify the denominator, and be familiar with working with fractional powers.